Okay, we're back with our drawing to CNC lathe tutorial. We have our model that we modeled in the last video. So let's cam this model into a lathe. We go to manufacturing. Just do this fresh. We're going to start with a new setup. We're going to make sure over here it is turned on to turning or mill turn, not milling. Make sure you turn it to turning or mill turn. Okay, it's going to automatically realize that it's only got two sides it can work from. It's going to give you a chuck and a Z direction. You can move this chuck up on the part and tell it where it's going to be on the solid stock so you don't crash into your chuck. We'll call it 2.5 inches in. Um, the only other real concern I'm going to have here on a lathe, which you can do a lot, you can add fixtures, you can select the models to do different spin features, but we're going to go into this work coordinate system. That is going to be your Z0. That's going to be your G54. That's going to be where everything works off of. I want to make sure that that is selected on model front instead of stock front, because stock front is talking about the material we're going to put in the machine. It depends on the way you like to machine, but we like our Z0 to end up being the exact face of the finished part. So I'm going to set Z0 right there. We're going to come to stock. It says that we are using a fixed cylinder that is 4 inches long, a solid cylinder, 2 inches in OD, which is exactly what we'd use, but we are actually going to use it at 0.125 thickness, which is 60 thousandths of extra material on both sides. We're going to go ahead and leave the program name and number 101 for this example. You can name it whatever you want. Our program is going to be cylinder one. If you put 0 here, it'll automatically just give you one work coordinate system, which is your G54. Well, I always put 1, that gives me G54. If I put 2, it'll give me another work coordinate system such as G55 or G54.1, depending on the system that we're using. You can also select this to select more than one work coordinate system instead of G55. We're going to say OK. So you can see this is our Z0, our G54 in pneumatic controller language. We've got some extra stock on both ends, so the very first thing we would do is face. We're going to utilize a CNMG tool to do that. If you don't have any of these tools in here, you can go down here to Fusion's tools and download their banks and utilize them temporarily. Just make sure you check the feeds and speeds for the inserts you are actually using. Okay, and it automatically is going to pick up the feeds and speeds that I've put in there for 4140 heat treated. And it's going to select the proper model front for us. Okay, so let's talk about this. So this is a detection zone, okay? So what this is saying is this is telling AI that you want it to work inside of these areas. When you get to working on boxes or inside thread dimensions, these will become very important. You'll want the outside radius and the inside radius to cover the area that you are working in, or it will not detect it. So these are all set currently to safe positions that I'm happy with. Okay, and it's going to import my tool now and show me that tool. And it's going to show me what it does if I simulate it. It's going to show me how it's going to do it. So it faces off that material there. Where they're going to move into turning the OD to rough it. Also with the same CNMG, we'll go to our roughing cycles, so it will detect our multiple depths of cut. It's asking where is the stop point for your roughing? Where's the finish point? Where is the where do you want it to pull out at? You can drag this or you can select an actual position. When you drag it, it just offsets it from the model back. So we know our part is 4 inches long, so we're just going to go to 2.2 for right now. That's where we want it to stop turning at. This is the inner outer radius that I was discussing before. It's detecting material from 1 inch all the way to 0 inch in radius. So that's 2 inches to 0 inches is where it's detecting currently. The clearance is telling it how far it needs to back out when it's moving around. This is passes. You have multiple options here for direction, cycle. These are for whenever you're grooving. You can turn this on to be a can cycle to output on your controller as a can cycle instead of an incremental cycle. It takes away a little bit of your options, but it saves a lot of lines in G code, a lot of lines. And then you can determine what stock you're going to leave on the OD, and this is per side, so it's going to leave 8 thou, which is nothing, but we're doing this for teaching purposes, so we're going to continue. These are your approaches and retracts. Yeah, you can get very detailed on Fusion 360. Okay, we can see it detected all of our lines. It detected everything we want to do. So now we're going to come in here with finish. One thing I like to do for the finish is I like to right click here and create a derived option. Cool. What that's going to do is it's going to copy everything from the last cycle and bring it into the new cycle. So that all of the things we've already selected are already going to be here. Now this offset here, this back offset, I'm going to bring it in a little bit because if I don't, it's going to give me an error code and say that it doesn't have enough room for the tool to pull out properly. It may still give it to me being 50 thou away, but we will see. Okay, it did give it to me. And it's saying lead out has been modified due to a gouge in remaining stock. And that's because of my settings and the angle and radius. I have it pulling out. It's saying, hey, this is going to get a little bit under a load right here, which is no big deal because we have very small cuts here. If you're concerned about that being popped up, you can select it and you can hide the warning on it and it ain't going to hurt anything. You can simulate as far as we've gotten now. You can see how it turns each process. And now we need to thread. Okay, so now we can thread the next part. Come in here, we're going to go to turn thread. We're going to select an OD threading tool. Going to select the thread face. Not the thread root, the thread face. We're going to back this away from the shoulder a little bit so it can pull out properly. Okay, now we should be able to simulate the entire process. Side A programming is complete. It's showing an error here because it's showing that the bottom of this holder is going to rub because this isn't quite the exact proper insert for this thread. But if you have your tool data in here properly, this is exactly how you do it. Now we will export this into G code. So we're going to come up here and we're going to post process. When we post process, we're going to have to find a post processor. I will say any FNUC will utilize the FNUC post. This is a FNUC turning post, a generic post for FNUC turning. I found it in one of the Fusion libraries, just looking for posts, but almost all the FNUC posts will work on all Fanuc controllers. So we now have the program. We're calling it NC Program 1. We'll post it. We'll override an old one I had. Here is our G code. Generated with labels. If we change the labels here, it will generate the labels we need here. If you guys have any questions or want to learn anything, please let me know. Leave me a comment. Thank you.